Intro. Voltage and current. Two of the most used words in electronics. But do you really know what they mean? And more importantly, do you know how they're different? In this video, we'll break down voltage and current in the simplest way possible, with clear analogies, real-world examples, and a visual mindset. Let's get into it. What is current? Let's start with current. Current is the flow of electric charge. Imagine a river. The water flowing downstream is like electric current. In a wire, instead of water, it's tiny particles called electrons that are moving. The more electrons that pass through a point in the wire every second, the higher the current. We measure current in units called amperes, or simply amps. If no electrons are moving, there's no current. Simple. What is voltage? Now let's talk about voltage. Voltage is what causes the current to flow. It's like pressure in a water pipe. The more pressure you apply, the more water flows. In a circuit, voltage is that pressure, the force that pushes electrons. If you have a battery, the positive end pulls electrons from the negative end. This difference in energy between the two ends, that's voltage. It's measured in volts. Relationship between voltage and current. So here's the important part. You can have voltage without current. That's like pressure in a pipe with a closed valve. There's pressure, but no water flows. But you can have current without voltage. Without pressure, nothing moves. In electronics, voltage is the cause. Current is the effect. Ohm's law. Let's make it more precise using a famous formula, Ohm's law. It says, V equals I times R, where V is voltage, I is current, and R is resistance. So, if resistance stays the same and you increase voltage, current also increases. If you increase resistance, but keep voltage the same, current goes down. It's a direct relationship. Voltage pushes, resistance slows, and current flows. The water analogy. Still confused? Let's bring back the water analogy. Voltage is like the water pressure. Current is the amount of water flowing. Resistance is like the size of the pipe. A big pipe has low resistance. More water can flow. A small, narrow pipe has high resistance. Less water can pass through. It's the same in a circuit. More voltage means more push. More resistance means more difficulty for current to flow. Real-life examples. Let's look at a few examples. Your phone charger gives out 5 volts, but your phone decides how much current it pulls based on what it needs. Power lines, they carry high voltage to move electricity across long distances, but they keep the current low to reduce energy loss. Even in your body, tiny voltages create tiny currents that move your muscles. Misconceptions. Here's something people get wrong. They think voltage is dangerous, but actually, it's current that can harm you. High voltage might be harmless if there's no path for current to flow. But even a small voltage, if it creates enough current through your body, can be deadly. That's why electricians wear insulated gloves to block the current, not just the voltage. Recap. Let's wrap it up. Voltage is the push. Current is the flow. Voltage makes current happen, and together, they power everything around you. They're different, but they're a team. Outro. Now, you know the real difference between voltage and current. No more guessing. No more confusion. If you liked this explanation and want more animated videos on resistance, power, or Ohm's law, let me know in the comments. Thanks for watching. And as always, Baba Booey.